In this lesson, you'll have learned so far how to identify the main characteristics of this landscape feature called the corrie. You'll have hopefully read this introductory text, which outlines what the corrie actually is. And what you'll have discovered is that the corrie is a landscape feature created by the movement of a glacier. Now, we're going to take that idea to explain all of the steps that result in the creation of this landscape feature. Because prior to the Ice Age, this is not what the corrie would have looked like. This looks like this today. You can go across Scotland and see these all over the place because of something the glacier has done. Okay, it has over deepened the hollow. And that's what we're going to look at. What we're going to look at is explaining how a corrie is formed. And in this part of the tutorial, we're going to examine how you can use a sequence of diagrams that you annotate in order to explain how this landscape feature was created. And then later on, you'll see another task which looks at how to write the answer without using diagrams. So there are actually two approaches to answering this question. This is a very common exam question. And in it, you are asked to explain how the corrie is formed. Okay? And to successfully do it, you will need to do a number of steps. Now, what I would like you to do is you will need a piece of paper. And if you don't have one in front of you yet, you'll need to go and get one. You'll need at least a pencil, and you might choose to use some color as well to highlight your diagram. Okay. What I suggest you do on your sheet of paper is you might want to divide it into 3 parts because we're going to be doing 3 diagrams. And you're going to want to give it a title that you can see up here. Okay, explaining the formation of corrie. You don't need this part here, just explain the formation of corrie. Now, you might want to pause it now and get your paper sorted and give it a title. Right, assuming you've got your piece of paper and it's divided into 3 parts, just before we go any further, when we do a diagram to show something, we generally cut the thing that we're showing in half. So I'm going to today, it's almost like I've taken a giant knife and I'm going to cut through this corrie, and then I'm going to spin this corrie on its side so we can see the corrie from side angles. Right now we're looking at it forward to the back. So this is the back wall here, and this is the pyramidal peak at the top. But when we draw a diagram, and I'll show you this as I'm drawing it, we'll see where this back wall is, where this corrie lake is here, or tarn, and then the open front here. So that's the key features that you'll see in the diagram as I draw it. Okay. Now, our first of our 3 diagrams, we're going to call it step 1, and this is the beginning of the Ice Age. Our first diagram is about the beginning of the Ice Age. So you can give it that little title if you want. Okay. Now you are wanting to fit all 3 diagrams onto one page, so don't make them too big, but make them clear and obvious to see. And what we're going to do is we're going to draw our hollow, because at the start of the Ice Age, we have a hollow. It's not very deep, it's just a dent in the mountain. So this would be the pyramidal peak, this would be the top of the mountain. It's not pyramidal yet though, because we've not had an Ice Age. And here's our hollow, and here's kind of a slightly raised front. And in this hollow, snow falls and builds up over time. Okay, layer upon layer over thousands of years of snowfall. Remember, it's an Ice Age, so it never melts. And gradually, what happens is the lower layers get compressed into ice, turning into a glacier. So let's just put those 2 labels on to show all of this. Now, I said they were annotations, not labels. So what is this? Well, we're going to put an arrow to this. This is a glacier. Forming high in the mountains in a hollow. Now, hollow is often north facing. This is the colder side of the mountain. Now, I don't need to say any more, but I will tell you why most corries are often north facing. And the reason for that is the sun never shines from the north. It rises in the east, it moves across the south, and it sets in the west. Therefore, the sun never shines from a northerly direction. And because of that, north-facing sides of slopes or hillsides or mountains don't see sunlight, and therefore they're colder. And of course, if you think about it, where is the most likely place that snow will not melt on a mountain? It will be somewhere that's colder, therefore the north-facing side. So I'm giving you some content here that's actually higher geography content, that stuff there, but I don't see any reason why at National 5 you couldn't include it to pick up some marks. Second label we're going to have to add is to what's actually happening as this snow piles up. So layers of snow pile up over years, and the bottom layers have the air pushed out of them, turning to glacial ice. So it's a bit like you're making a snowball. You take snow in your hand, you squeeze it, and it becomes harder. And when you're squeezing it, what you're actually doing is you're pushing the air particles out and you're pushing the ice crystals closer together. And that leads to the glacial ice forming. So at the bottom of this, we've got the glacier starting to build. Okay. Our final label before we crack on to our second diagram is our glacier starts to move, because it's now getting pretty big. It might be hundreds of meters thick. Obviously, this doesn't happen over one winter. This happens over hundreds of years worth of winters. So as glacier grows, it begins to move in the hollow due to gravity. That is one of the most important statements to add to your diagram, because without the glacier moving, you'll get no erosion. And we're going to talk more about erosion in a minute. And without erosion, we don't have our hollow getting deeper. Okay, so that's step one, the beginning of the Ice Age. So let's just move on to step two. So you want to draw a new diagram now. We're going to have step two. For new diagram, this time, let's just start with the outline of our diagram. We're going to make our hollow. This time, we're going to make it much deeper, because we're going to show that the glaciers now started to do some erosion. Okay, so it's much deeper than it was in our previous diagram when it was just a small hollow. And this is where we can start to see the steep back wall. There we have the steep back wall, the little blue lake, the tarn, that will end up at the end of the Ice Age being in this area of the hollow here, and up here would be the mountain peak. Let's add our glacier. Now our glacier is so large, it's grown right up to the back of the glacier, and it's actually outgrown the hollow, and it started traveling down the mountains. And that's an important thing. Outgrowing the hollow, and you'll see that in some of the video footage from earlier lessons, is what leads to the U-shaped valley being formed further down. Now I'm going to add a little arrow here, and that's going to actually be my first little label, because I'm wanting to show that our glacier has outgrown the hollow. Okay. And we have a label that you want to make sure you add. One other thing, now that's an annotation. We need to add a simple little label. We've got to know what that is, because we don't know what that is, especially if you're not using color. It would just be, it wouldn't show up. So this is our glacier. Now, our glacier is moving, and there's an actual type of movement that it does. So I'm going to just thicken up my arrow here to show this. Kind of like a circular, but an arrow traveling in a circle. Now, what I'm doing there is it doesn't just grow down and out of the mountain. It's almost like spinning inside the hollow, rotating round and round. And that's really important, because that's part of the thing that leads to the erosion that results in our hollow getting deeper and deeper. Okay, it's a bit like if you were scratching away at something on a table with maybe a knife, and you just kept scratching, scratching, scratching. You would make a hole in the table. It would get deeper and deeper the more you scratch. Well, that's what the glacier is doing. Instead of it being a table, it's scratching away at the mountain. So glacier moves inside the hollow in a process known as rotational slip, which results in erosion happening. Okay. Right, what else have we got? Well, we want to talk a little bit about erosion now. Now, to do that, I'm going to show you something that will be happening at the back of my glacier. Now, let's just say this is the part of the mountain, okay, that area marked in red. And what happens is the glacier is touching, it's all around here, okay, it's frozen around this part of the mountain. It's actually, maybe there's a slight crack here because of freeze thaw. Water from the slightly melted glacier is now getting behind this part of the mountain. And the glacier is freezing around this bit of rock. And what will eventually happen, because the glacier is moving, is it will rip this rock away from the mountain. Okay, now that's the first of the two main processes of erosion that happen, that the glacier does to the mountain. Okay, so glacier freezes around part hollow and rips it away from the mountain. It moves in a process known as, now you might remember this from a previous lesson, the last lesson actually, plucking. So when rocks, parts of the mountain are literally getting ripped away by the glacier sticks to them and then it just pulls them up. And these can be small little boulders that you could hold in your hand. These could be rocks as big as the room that you're sitting in right now. So whole massive chunks of glaciers get ripped away because the glacier is actually stuck to the mountain and ripped it away. And that just shows you how powerful glaciers are. They are, remember, they're incredibly large, thick pieces of ice that is moving. Now, because of all this plucked material, our glacier is going to have tons of this stuff that's been ripped up all around the bottom, okay? Because it's been ripped up from the mountain because of plucking. And that means the bottom of the glacier is a bit like sandpaper. So if you think about what sandpaper is, it's just a piece of paper with little grains of sand glued to it. Well, the glacier is a bit like sandpaper, but instead of little bits of sand, it's got giant boulders glued to the bottom of it. Okay, and because it's got all these boulders glued to the bottom of them, they start sandpapering the hollow deeper and deeper. Okay, and that's also a process of erosion. So rocks stuck to the bottom glacier, sandpaper, hollow even deeper. In an erosion process known as erosion. And there you go. We've got two processes of erosion, plucking and abrasion. We know this thing called rotational slip, and we've got our glacier outgrowing a hollow. Now that's step 2. I should just add to your title, during the Ice Age. Make sure you've added that. And that brings us to our final diagram, which shows us the Corrie after the Ice Age. So this is step 3. Ice Age. Right, so back to our original diagram, we've now got our really steep hollow. Okay, and in it we're going to have a small little round lake that we had in the original photograph at the start of this little lesson. Okay, and we're just going to add some labels to show what's happened. I'm also going to add some boulders that have rolled off since the end of the Ice Age and built up at the bottom of the slope and introduced to these in the first part of today's lesson. So those are what we have down here at the bottom of our mountain. Is we've got a little scree slope. And the reason we've got it, scree slope builds up at the back of the corrie due to freeze or weathering on the mountain above. Okay. What else have we got? We've now got a very steep back wall. That's that bit there. So we've got a very steep back wall. It might be so steep actually that it's a cliff. Rock climbers tend to love the back walls of corries because they're perfect for climbing up. And then we've got our small little lake inside our hollow. So here we have our small round lochen. slash lake, known as a cairn. And our front is slightly raised. You might remember that that was known as the lip of the corrie. Right, there is 3 steps, 1, 2, and 3, of how our corrie is created. If we just jump back, you're going to want to make sure all 3 of these are drawn on one sheet of paper. You're going to want to photograph that sheet of paper, and then you're going to want to put it into your class notes. And we just go back, we should now be able to explain all the steps that led to the formation of the corrie. Step 1, what happens at the beginning with the glacier forming, then what does the glacier do to the mountain to create the deeper hollow, and then when the glacier melts, what we left with. Okay, so you go and use all of these steps to draw your diagrams and put them into your class notes.